Hi guys, how you doing? This is another lesson, digital lesson coming at you because we've got lockdown, which is starting to get a bit old now. I'm sure you're finding similar kind of issues that I am. My wife's really getting on my nerves at the moment. She thinks she's so smart. She keeps telling me all these facts. She told me the other day that an onion is the only food that makes you cry. So I threw a coconut at her face. Anyway. Today we're going to look at experiments. That's the next stage of research methods. A couple of different types, but it's going to follow a similar pattern as the previous lessons. So looking at experiments. Okay, so we're going to talk about experiments, and we're going to do this one slightly differently to how we've done some of the other methods. Instead of giving you like an example that's set apart from and has its own box that you need to fill in, you're going to fill out the example as we go through and as it relates to some of the key aspects of experiment. And the example that we're going to use is one that you should be familiar with, which was done by Rosenthal and Jacobson. Looking at like labeling and how that affects students' performance in school. So experiments, they have a kind of set structure. This is going to sound a lot like a GCSE science lesson. This is all stuff that you should really know already. So I'm just going to recap it relatively quickly. You start off with the hypotheses. Okay, this is like a prediction of what should happen with a certain thing. Okay, so if we take our example of Rosenthal and Jacobson, the hypothesis was that the labels that teachers have, particularly if their kids are labelled as bright or high achieving, will affect how well their academic performance is. Okay, so the prediction was if teachers have a label of bright, if they think these kids are bright, then they'll teach the kids differently and the kids will do better. Okay, so that was the hypothesis for Rosenthal and Jacobson. And then the next step is to get yourself two groups, okay, two groups of participants, and they're called the control group and the experimental group. Now the control group, the one that you use to kind of compare your results to see whether the thing you're looking at has actually made a difference. And they're left entirely, as they are. They're left to behave completely naturally and develop completely naturally as they would have otherwise. They're not interfered with or manipulated in any way by the experimenter. But the experimental group, they are the ones that are messed with, essentially. They have one factor, and one factor only, manipulated by the researcher. Okay, so if we go back to our example, Rosenthal and Jacobson, their control group was 80% of the kids in this cohort that weren't given a label. Okay, and the experimental group were the 20% of kids that were given the label of like high achieving. So their teachers were told that these 20% of the kids, they were going to be, over the next year, they were going to make massive progress and do really well and be high achieving. And they were called the spurters, or like the spurter group, so a high achieving group. Now, for those two groups, for Rosenthal and Jacobson, they were randomly assigned into the experimental group or the control group, but the teachers didn't know that, which is part of the point. But those were the two groups for Rosenthal and Jacobson. Now that one factor that gets manipulated by the researcher, that's known as the independent variable. Again, you should be aware of this. The independent variable is the one thing that the researcher is interested in and looking at to see how it makes a difference. And then the impact of that independent variable, how it makes a difference, is called the dependent variable. Okay, so how it makes a difference. A way that I remember it is the independent variable is the one thing that you change, and the dependent variable is the one thing that you measure. So to help kind of crystallize that, if we go back to our example of Rosenthal and Jacobson, the independent variable was the labels given to these kids, and the dependent variable was the thing that they measured was how well those kids performed academically. Okay, so how did the IV affect the DV? How did the label affect the academic achievement? That was what's going on. And all other factors would have been completely controlled, or in an experiment should be completely controlled. Okay, the only thing that should ever change are the IV and the DV, because that way you can know for certain that there's a cause and effect. You know that the IV, the independent variable, has changed the DV, the dependent variable. Okay, and so that cause and effect is really crucial when you think about the natural sciences, physics and chemistry and biology. the key thing there is, knowing that this aspect, this IV, has changed the DV, and that's why we've got the cause and effect, and that's why we do these experiments. Now we need to consider the strengths and weaknesses of experiments in general, and then look at some specific types of experiments and how they're different. Okay, so before we go into the strengths and weaknesses of experiments, we're just going to have a look at the different distinctions between a couple of different types of experiment, because that way when we do the strengths and weaknesses as a whole, I'll be able to talk to you about the kind of comparing one with the other and how these kind of things pair up, because that's helpful for how you write about them in an essay. So there's a couple of different methods of experiment. The main ones are what's called a lab experiment, laboratory experiment, and then a field experiment. So a laboratory experiment, it's something that's conducted in a very highly controlled environment. It's hence the name laboratory. So every single variable, other than the independent and the dependent, is controlled. And we'll talk about why that's a good thing later. What it does mean, though, is that that's a very artificial setting. It's not a natural, real setting. And obviously, it's, people would get invited to come and be a part of it. It's not part of their everyday life. They'd be invited to come in. It might be a university or, something like that, a building like that. And you'd go and take part, and you'd be fully aware that you're involved in an experiment. Now, on the other hand, field experiments are, like the name suggests, done in the field, done in the real world. So they are a lot more natural, real-life settings. It's the surroundings that the participants would be naturally used to. It does mean it's harder to control every single variable, because obviously it's the real world, but you'd still do your best to control as much as you possibly could. And often, the majority of the time with field experiments, the participants don't really know that they're being a participant in the experiment until after. Which, again, we'll talk about why that's good in a little bit as well. But it's different. That's one of the key differences with the lab. The lab experiment, they know exactly, they know they're being watched. They know they're part of the experiment. Whereas in the field experiments, they don't know. And Rosenthal and Jacobson's experiment, that was a field experiment. It was done in schools. And the teachers were unaware, and the kids were unaware, that they were part of the experiment until after. We'll talk about the strengths and weaknesses of that in a second. Now, you've also got something called the comparative method. Technically, this isn't actually an experiment, because no variables are manipulated. You haven't got the independent variable there with the researcher directly manipulating something. But it does try to follow a similar procedure to the other two, and it's all about trying to prove cause and effect. What they do is they get data that's already kind of out there, already raised. So it's a secondary, uses secondary data, secondary sources. And the researcher tries to identify two groups. Again, they try and make them as similar as possible, apart from one key factor, which is similar to the independent variable. But two different groups of people that are very similar, other than one key aspect that the researcher's interested in. And then they compare data between those two groups about whatever it happens to be that they're looking at, to see if that one big difference had any effect. Now, this might make more sense if I tell you about the example. So Emil Durkheim did quite a famous study on suicide. Now, obviously, you can't mess around with manipulating an independent variable with suicide. Durkheim, he predicted, his hypothesis was that basically being socially isolated would lead to higher rates of suicide. So feeling more lonely, essentially, would lead to more people killing themselves. And so he took two groups of people. Now, the ethics of doing a proper experiment on this would be, off the chart, so it would be completely unethical. But he took two groups of people and got data on two groups of people, and they were very, very similar, other than their religion. So he looked at Catholics and he looked at Protestants, and he made the judgment that Protestants were far more socially isolated than Catholics were. But they were very similar in every other respect. So you got two groups, very similar, one key difference. And he found that it was the Protestants who had significantly higher suicide rates. So you're trying to prove cause and effect, but without actually manipulating any variables. Okay, so those are your three different types, or two different types and plus one bonus thing. We're going to look at the strengths and weaknesses of them now. Okay then, so we're going to cover the strengths and weaknesses of experiments. Now, what I'm going to do for some of these strengths and weaknesses is they go in pairs. Because you're comparing lab experiments with field experiments, and often a weakness of one leads to a strength of another. And when you're writing in an essay about them, that's what you want to be looking for, is a kind of point and counterpoint discussion and comparison between lab and field experiments is often going to be the most regular thing. Same thing with like structured and unstructured interviews, that kind of participant and non-participant observation, those kind of things. But we'll go through them for experiments and you'll be able to write those down in the relevant columns as we go through. Make sure you highlight this kind of point-counterpoint idea to link together different ideas that would work really well in paragraphs in an essay. So we'll start with the biggest weakness of experiments is to do with validity. It's what's called the Hawthorne effect. Now, I've talked to you about this before. And it's basically the idea that when participants know that they're being watched, which with a lab experiment, that's what happens, is there's no way around that really, because they get invited into this highly controlled environment. So when they know they're being watched, they change their behavior. They don't behave in the way they naturally would. Which means that it's not a valid picture. The results aren't a valid picture of what actually happens in society. Now, that's a weakness of your lab experiment, but a strength of most field experiments, because the participants don't know they're being watched, they don't know they're being part of an experiment. It means that they're avoiding the Hawthorne effect, and therefore they're behaving how they naturally would, which makes it much more valid. Okay, so strengths and weakness there that pair up well. But with field experiments, there's a trade-off. So you might get more validity, but you've got ethical issues in that they don't know they're being watched, and so you've got a fully informed consent. And also, it's a lot harder to control variables in the real world. So there's some practical issues as well. So the trade-off for higher validity, theoretical issue, is a practical weakness and an ethical weakness. Okay, so you can see how it all works together. There's all, these things connect with each other and relate to each other, and that's how you need to be talking about them in an essay. Now, strength of lab experiment in particular is that they're extremely reliable. That's because they're clearly laid out step by step, with very precise instructions and measures and controls, which means that someone else wanting to do the same thing, they've got all the kind of information there for them, so they know exactly what they need to do to make it the same. And when you can make it the same, that means it's easily replicated. That makes it reliable. Now, so that's a strength of your lab experiments, but not so much a strength of your field experiments. Okay, it's a lot harder to replicate exactly because there's so many other things going on that are harder to control in a field experiment. Another issue with validity, so weakness of validity, is that particularly lab experiment is it's artificial. It's not a real life setting, okay? Because you're going, out of your day-to-day life to go to this lab and take part in the experiment. It's not a real life setting, and so we can't say that the results are valid and true to real life. Again, you can flip that round and say that's a strength of field experiments, is that it is an everyday setting. It's a real life situation. Even though it's being manipulated, it's a real life setting, and therefore we can say the results are valid and an accurate picture of real life. Big weakness of both of these types tend to be that they're so small scale because of the nature of them. You can't do them for thousands and thousands of people. So they're so small scale that you can't generalize the findings. Okay, they're unrepresentative. We can't say that everyone in society would behave in the way that our participants did. And most of the time we're talking about dozens of people rather than hundreds or thousands. Makes it very difficult to generalize. Ethically speaking, the strength of the lab experiment, we've already kind of touched on this, is that you can get fully informed consent. People can come in and they'll know exactly what going to happen and what's going on with them. And therefore they can say, yes, you know what, I consent to this, let's go ahead. Weakness, though, of field experiments. You can't get that fully informed consent a lot of the time because you lose the validity and just because of the nature of the type of method. There's also the issue of harm and deception, which actually could come in both lab and field. You're going to look for task 5.2, you're going to look at an experiment by a guy called Stanley Milgram, which involved a significant amount of deception and harm that was done in a lab experiment. When we think about Rosenthal and Jacobson, that involved a level of harm as well, in that there were some students there, they didn't get randomly assigned the positive labels, the bright labels, which meant that potentially they didn't do as well in education as they would have done if the teachers had just hadn't been given any labels. So there's issues there of ethics in terms of harm, and that's often the case. So we need to be careful about that for both types of experiment. Practically speaking, we could say in a lab that actually, because you've got control of all of the environment, it is possible and relatively easy to control all the variables. And that's, practically speaking, that's a good thing. That also leads to the validity issue in terms of proving cause and effect. We know that it is this one thing that has caused this other effect. And so that's a big thing, particularly for positivists, who I'll talk about later. But we could also say a weakness of field experiments is it's very difficult to actually isolate and control all of the different factors in society that might affect someone's behaviour. If you think about, for example, crime and reasons why people become criminal, there's so many different aspects of someone's life that would contribute to them becoming a criminal that we can't necessarily say that we can just isolate and control all those different things. So practically the same kind of idea can be a strength or a weakness, and you can argue either way. Theoretically, then, we need to talk about positivism and interpretivism. The positivists, they love lab experiments. They're wanting sociology to be like a natural science. So they want to use the same methods. They want to be able to prove cause and effect. Now, remember, they think about society as something that's separate from human beings, something that's separate and like above and can control human beings. Which means we want to look at the cause and effect. We want to, humans don't have a say in it. There's some cause that's beyond them that initiates an effect in them. Their behavior is controlled by cause and effect. And so we need to look at these cause and effect and establish exactly what they are. And so a lab experiment is perfect for that situation. The counter argument is, and the interpretivists would say, the problem is, and the difference is, compared to the natural sciences, sociologists are studying people. And people have free will. People have choice. When you think about plants and rocks and stars and asteroids and things like that, they don't have choice. They don't have consciousness. People do, which means that cause and effect doesn't really work. It doesn't really relate to human beings. Cause and effect is society causes a change in us, or a particular social institution causes a change in us. Interpretivists would disagree, so positivists would say that. Interpretivists would disagree because they'd say, well, humans have the ability to think and choose how they respond. Okay, so cause and effect doesn't work and doesn't make sense, and so lab experiments for interpretivists aren't a valuable method. Field experiments and the comparative method is something that the interpretivists would choose over lab experiments, most definitely, because you can get at more of the meaning of things. So, for example, Rosenthal and Jacobson, it was the meanings and beliefs that the teachers had in their heads that then altered something else. And that is something that interpretivists would think that's what we need to look at. The comparative method, you need to have a specific, some strengths and weaknesses of that, but not a lot, because really when you're going to be talking about experiments, your main focus is going to be lab or field experiments. But with the comparative method, strength of it is you can study some of the things that you wouldn't be able to study otherwise. For example, suicide. You can't mess around with the independent variable to do with suicide. It's massively unethical. So this is the only way of kind of experimenting. Technically, it's not an experiment, but it's the only way of experimenting in some areas of society, in some aspects of society. And that's a strength, that's a positive for it. But weakness is that you can't prove the cause and effect. Because you're not directly manipulating the variables, you can't prove the cause and effect. Which means that there's a validity issue there. We can't know for certain the thing that we think is making the difference is the thing that's making the difference. It might be that there's some other factor in life that caused these people to commit suicide, or whatever it happens to be. So you can't prove cause and effect. That's an issue with validity. All right, you've got lots of strengths and weaknesses there. Often they're paired up and relating to other strengths and weaknesses. So try and communicate that in your notes in the table. As you go through and write that. If you need to, go back and re-listen to what I've said several times to make sure you're getting all the connections and all the links, and write that nice and clearly. So task 5.1 is completing all of that Word document with the definitions, the example, notes on the different types of experiments, and the strengths and weaknesses. Okay, so the last thing I want you to do when you're looking at experiments is on the Word document, task 5.2, I want you to click on the link that's on there. It'll take you to a YouTube video looking at a replication of an experiment done by a guy called Stanley Milgram. So it's Darren Brown who's replicating it, but that's neither here nor there. What I want you to do is watch the video and answer the questions, and in particular go into as much detail as you can for the last question. And then you get that document saved and you email it over to me by the end of the day on Wednesday. All right, and I'll see you next time.